Hi, everyone. Today is April 20th, and we're going to be talking about trigonometric functions of any angle. Okay. I feel like there should be some intro music here. All right. Okay. All right. So, when we talk about trig functions, and I want to say this. This is the most important thing in this whole unit, and we're going to spend several days on this. Okay. But this is we've been building up to being able to do this. Okay, and that's finding sine of like 7 pi over 6 and cosine of 2 pi over 3 and tangent of 4 pi over 3, and we're building up to doing all of that. Okay, that's what we've been building up to. So you had to understand the little pieces along the way, and now we're going to put it all together. All right. Okay, so really when we talk about trig functions, we're talking about a point that's moving on a circle. Okay, so here's my point. Okay, and this right here is my radius. Okay, that's the radius of the circle, right? So that would be my R. Okay, and then the angle that I rotate, whether right now this one's being drawn into the first quadrant, but even if I rotate all the way into the second quadrant or third quadrant or fourth quadrant, where we have angles that are bigger than 180 degrees, okay, then that angle that we rotate is always called angle theta. Okay, now this point right here has an x coordinate and a y coordinate. Okay, so I'm going to use different colors for this. All right. So my X, I'm going to draw in red. Okay. And my Y, I'm going to draw in blue. Whoops. Didn't mean to move that on you. Comma. And then Y. Okay. So that means from this point down to the vertical, or not the vertical, the horizontal axis, the X axis, right? This distance right here is equivalent to this y coordinate. So this is y. Now in this quadrant, y is positive. In this quadrant, which is the second quadrant, y is positive still. But when you go down here into the third and fourth quadrants, these two quadrants, your y is going to become negative. So it's not necessarily the leg of the triangle, because this is going to be a right triangle. The leg of the triangle is positive, that length is positive, but it's a direction. So it's kind of like a vector from physics, okay? Those of you who have physics, all right? So right here's my right angle. And then that means this horizontal leg right here is my x. In this quadrant, my x is positive. But if I'm in this quadrant, this second quadrant right here, then my x would be negative. Here in the third quadrant, my x is negative. Here in the fourth quadrant, my x is positive. And this r, my radius, is always positive because it's a length, okay? So from the other day, we know that sine of theta, sine of angle theta, is always the opposite leg over the hypotenuse. Well, this changes when we do this way, okay? I shouldn't say it changes. It's still the same. It's just we're not gonna call it the opposite leg anymore in the hypotenuse. Instead, we are gonna call it y over the hypotenuse, which is r. So sine theta under these conditions, which is the true definition of trig functions, it's the y coordinate over your radius r. So sine theta is y over r. And cosine of angle theta is the adjacent leg over the hypotenuse. Well, now the adjacent leg is now called x, and the hypotenuse is called r. So cosine theta is x over r. And it doesn't matter where you rotate, the cosine of angle theta will always be, the adjacent leg will always be your x, and the hypotenuse is always going to be your r. So you need to know these two, okay? Well, actually not just these two. You also need to know this one. Tan theta changes on us too, okay? So tan theta in this circle idea, okay, is the opposite leg over the adjacent leg. So the opposite leg is your y, and the adjacent leg is your x, okay? So tan theta becomes y over x, okay? So these are three new ways of looking at sine theta, cosine theta, and tan theta, all right? And we also still know that if we're only given two of these, we can find the third one because we can still use the Pythagorean theorem. So x squared plus y squared is going to equal r squared because it's a right triangle. We formed a right triangle by doing the x and the y coordinate, okay? All right, we are ready to do some problems now, okay? That's it. I mean, that's the idea behind all of this today, okay? All right, so let's go down and we're going to do example number 1. Okay, so for example number 1, use the given point, and the point has an x and a y coordinate, okay, on the terminal side of angle theta to find the values of sine theta, cosine theta, and also tan theta, okay? All right, so here, this is my rotation, right? This is my angle of rotation. The angle put the point into the second quadrant or in the upper left quadrant. And what do we know about this in this quadrant? We know our x's are negative and our y is positive just by looking at this. But if I didn't give you the point, you would know that your x has to be negative and your y has to be positive. Okay, so I'm going to draw my right triangle. Now, this is very, very important, okay? You draw your legs. The vertical leg is always going to be drawn to the x-axis. Do not, okay, this is like the reference angle. Do not draw it this way. You will get your answer wrong. It's the wrong thing, okay? Do not draw from the point horizontal. From the point, draw it vertical, okay? So straight down. And I have my right angle here. So because I gave you the coordinates of this point, I know that this horizontal piece is -3. Okay, it's direction along with length. So the direction is negative because I'm over here on the left side, and the length is 3. Okay, now this is also direction and length. It's the square root of 7. So I know my y is the square root of 7. So I know this leg is represented by the square root of 7. And now I don't have this. I don't have my radius. I don't have my r. Okay. So to do the sine theta and cosine theta, I need to know what r is. Okay. I actually, at this point right now, could do tan theta. I could figure it out. Okay. All right. But I want to do these two first. Okay. All right. So to get this r, I can use Pythagorean theorem because I know that -3 squared plus the square root of 7 squared has to equal r squared. So -3 squared would be 9 plus, by the way, if you don't put parentheses on -3, you wouldn't get 9. You'd actually get -9. So the -3 has to have parentheses around it, okay? And the square root of 7 squared would be 7. That's equal to r squared. So 9 plus 7 is 16. That's equal to r squared. We're going to square root both sides. Okay, now this actually becomes the absolute value of r, right? And so we could get two answers. We could get the positive and the negative, right? But I'm going to cut the negative part out because I know r is a radius of a circle and it has to be positive. So my r in this case has to be 4, okay? Because the square root of 16 is 4. Okay, so now I know my r. I know this r is 4, okay? So what is sine of angle theta? What's the sine ratio for this angle of rotation? Well, it's my y over my r. My y is the square root of 7. My r is 4. So this is simply the square root of 7 over 4, okay? Cosine theta is my adjacent over my hypotenuse. My adjacent now is called x. So it's going to be -3 over my hypotenuse, which is r. So -3 over 4. Or you could also call this -3/4. Either one's right. Okay. All right. And then tan theta, which we could actually have done right off the get-go because I was given my x and my y, right? Tan theta is equal to my opposite leg, which is now called y, and over my adjacent leg, which is now my x. So it would be the square root of 7 over -3. Or you could write that as negative square root of 7/3. okay? Either one, I mean, if you write it like this, perfectly right, okay? Nothing wrong with this. If you write it like this, perfectly right. Both of these are just two different ways of seeing the same thing, okay? All right, that's example one. Let's go to example number two. Before we get into example two, sorry about that, okay, we need to talk about special right triangles. I forgot about this, okay? All right, so some angles that we need to know just right off the get-go, like we just know them, okay, is pi over 6, okay? Pi over 6 is equivalent to, okay, what in degrees, okay? So if we take pi, and pi is the same as 180 degrees, pi and 180 degrees are the same. So this is taking pi and breaking it into 6 equal pieces, right? Or 6 angles, okay, of equal size. So if we take 180 degrees and divide it by 6 or break it into 6 equal angles, each angle would be 30 degrees, okay? So pi over 6 will always be 30 degrees, okay? Pi over 3 is taking the angle pi and breaking it into 3 equal angles. Well, pi is the same as 180 degrees. So if you take 180 degrees and break it into 3 equal angles, each angle would be 60 degrees. So pi over 3 is equivalent to 60-degree angle, okay? And then we're going to talk about pi over 4, okay? And over here, pi over 4 is taking pi, which is 180 degrees, and breaking it into 4 equal pieces, right? So if you take pi and break it into 4 equal pieces, or you take 180 degrees and break it into 4 equal pieces, each piece would be 45 degrees. So pi over 4 is equivalent to 45 degrees. Okay. Now, this has to do with special right triangles, which you learned last year in Math 2, okay? So this pi over 6 right here is really a 30-degree angle. And pi over 3 is a 60-degree angle. And here we have a 90-degree angle, okay? And we need to commit these to memory. You need to take the time and know where everything goes, okay? There are 3 sides. There's going to be 3 sides, and we're going to take the simplest version of this, okay? And we are going to look at the square root of 3, the side length of 1, and a side length of 2. Now, this square root of 3 is between the square root of 4 and the square root of 1. This square root of 1, or 1, is the same as the square root of 1, and 2 is the square root of 4, right? So the square root of 3 is in between these two, okay? So the smallest of these is 1, the biggest is 2, and so the middle size one is the square root of 3, okay? So this is just a way to keep track of where everything goes, okay? Now, from last year in Math 2 or geometry, always the smallest side is always opposite the smallest angle. Well, which of these angles is smaller? Well, pi over 6 or 30 degrees. So what has to be opposite that is a 1. So opposite 30 or pi over 6 is always 1, okay? Opposite the pi over 3, which is 60 degrees. Well, let me do my biggest one first, okay? So of these, which one's the biggest? Well, it has to be 2. That has to be opposite your biggest angle. So 90-degree angle right here, that's our biggest angle. So this would have to be 2, which is left with this leg right here, which is the square root of 3, okay? Which is in between 1 and 2. So that's just one way to help you remember where to put everything, okay? So opposite pi over 6 is always going to be a 1. It could be 1 or -1 because this is going to be either, this is going to be one of the legs. And depending on which quadrant it lands in, this is either going to be 1 or -1. This is also a leg, and depending on which quadrant we land in, you understand what I'm talking about in just a minute, okay? You'll understand that the square root of 3 could be either positive square root of 3 or negative square root of 3. This too is going to be the hypotenuse or the radius of our circle, okay? So it's always going to be positive 2, okay? All right, so over here, pi over 4, these are 45-degree angles, okay? And these two legs have to be the same because it's an isosceles triangle from Math 1, okay? Maybe even before Math, or not Math 1, Math 2, okay? So for this one, we're going to use side lengths of 1, 1, and the square root of 2. Okay, now both of these are the square root of 1, right? Okay, so these are the smaller, this square root of 2 is bigger than these two. So the square root of 2 must go on the hypotenuse or the radius. So that's going to be square root of 2. And then this leg and this leg have to be the same because this is an isosceles triangle. And remember, opposite sides have to be congruent. Okay, so this is going to be 1 and this is going to be 1. So for a pi over 4, 90-degree angle, right, the sides are going to be 1, 1, and the square root of 2. And the square root of 2 is going to be the hypotenuse. Okay? All right, so we gotta commit to memory on a pi over 4, or a 45, 45, 90. The legs are both 1, and the hypotenuse is the square root of 2. For 30, 60, 90, opposite the 30, or the pi over 6 is going to be 1. Opposite pi over 3 is going to be square root of 3. Now, that's something that helps people remember. Okay, we have a 3 here. Opposite, we're going to have square root of 3. Okay, that helps people to remember it too. I've used that too. Okay, but you got to commit these to memory. Okay, memorize. We want to memorize side links. You've got to commit it to memory. Otherwise, this is going to be really, really hard on you. Okay, memorize side links. And these are the only two you need to know. Okay, memorize side links of special right triangles. Okay, now we're ready for example 2. Okay. All right, for example 2, what we want to be able to do is find the value of all three trig functions for the given angle. Okay. So this angle that we've rotated, the initial side right here is on the positive x-axis. That's where we start, and we rotate, and this terminal side winds up being in this bottom left quadrant, which is the third quadrant, okay? And the angle is 7 pi over 6, okay? Now, if I do a half rotation to right here, I know that that is 6 pi over 6, okay? Now, I'm going to rotate a little bit more to get down in here, right? But how much more did I go from 6 pi over 6? Well, I need to get to 7 pi over 6. So that's 1 pi over 6. Now, what that allows me to do is to realize this reference angle, remember that's my alpha, that's pi over 6, okay? And now what I'm going to do is I'm going to draw, okay, this point that's moving along the x-axis that has a rotation, right, and a radius. I'm going to draw to the x-axis, okay? Do not, I can't say this enough, don't draw horizontal, okay? From this point, you're always going to, from your terminal side, you're always going to go vertical, either up or down to your x-axis, okay? Now, because, and this is a right angle right here, okay? Now, because this angle is pi over 6, this angle right here would have to be pi over 3, because this is a 30, 60, 90 special right triangle, okay? Now, what you need to know is that opposite pi over 6 is going to be 1. But because I'm going down, that has to be a negative 1. Now, why does it have to be negative 1? Because that represents the y-coordinate here, and the y-coordinate in this quadrant would have to be negative, okay? Because I'm going to get to this point. I'm not just, there's two ways you could rotate, but the other way is to go left and down, right? Down is negative, left is also negative. So I know this is also going to be negative, okay? Opposite pi over 3 is going to be the square root of 3, but not just a square root of 3 because I'm moving left, like I just said. It's going to be negative, okay? Now, this is my radius of this circle, which has to be positive. So on a 30, 60, 90 right triangle, the hypotenuse or radius is always 2. Okay, so given the angle of rotation, okay, that gets me the reference angle. The reference angle gets me the special right triangle. The special right triangle gets me the three sides that I need, okay? All right, and we're ready to do this, okay? So the angle we rotated is 7 pi over 6. So that's the trig function. We're finding the trig functions of that angle. So sine of angle 7 pi over 6 is equal to, well, it's your opposite over your hypotenuse. Our opposite is negative 1, so it's also our y, right, over our r, which is 2. So this is negative 1 over 2, or negative 1/2. If you left your answer as either one of these, it's perfect, okay? Cosine of angle 7 pi over 6, okay? So cosine of angle 7 pi over 6 is your x over your r. So it'd be negative square root of 3 over 2. You could also write that as negative, the fraction, right? Negative square root of 3 over 2, okay? Again, either one's right, okay? And then we have tangent of 7 pi over 6. I'm going to slide this up just a little bit so you can see it a little bit better. Okay, so tan of 7 pi over 6 is equivalent to your opposite over your adjacent, or your y over your x, okay? So that'd be negative 1 over negative square root of 3. That's equivalent to 1 over the square root of 3. Now, that's a perfectly fine answer, but there's a better answer. Why? Because you have a square root in the denominator. So we want to simplify this. It's called rationalizing this denominator. If you recall, we've done this before, right? And we want to multiply the top and bottom by the square root of 3. So I'm going to do this in a different color, okay? If you can do this mentally, go for it, okay? So an equivalent answer, and remember that square root of 3 over square root of 3 is 1, so we're multiplying by a version of 1. And this would be 1 times the square root of 3, which would be the square root of 3, over the square root of 3 times the square root of 3, which would be the square root of 9, which is 3, okay? And so tan of 7 pi over 6 is 1 over the square root of 3, but a better value for this, or not value, okay? A better way of writing the same answer, an equivalent answer, is to write it as square root of 3 over 3. We're going to need to be able to know these, okay? Square root of 3 over 3, okay? We're actually going to have to, I'll explain later, but we need to know that these two are equivalent. That's the key here. We have to know that 1 over the square root of 3 and square root of 3 over 3 are actually the same number, okay? All right, let's go to the next problem, all right? So for this next one, okay, I'm rotating 7 pi over 4, okay? So here's my initial side. That's where I start. I'm always starting on the positive x-axis. I'm going to rotate with a positive angle counterclockwise to 7 pi over 4, and that terminal side is right here in the 4th quadrant, the bottom right, okay? So what do I know? I know that if I rotate to right here and stop on the negative x-axis and only rotate to there, that would be 4 pi over 4. And that would be a half full rotation, right? If I go, so every half rotation would be 4 pi over 4. That would put me over here at 8 pi over 4. So if I did a full rotation, and I did the arrow all the way up to here, that'd be 8 pi over 4, right? Okay. But that's too much rotation, right? Because really I only did 7 pi over 4. So I got to back off to get to my terminal side. How much do you have to back off? Well, you have to back off from 8 pi over 4 to 7 pi over 4. That's a difference of pi over 4. So that tells me this reference angle right here is pi over 4. That's my alpha from before, okay? So here's my point right here. Okay, and once you get good at this, you're going to do this. You're going to be able to get faster and faster and faster and do this really fast, okay? I've seen it over 27 years of teaching that people get fast at this, okay? So this is my right angle, okay? If this is pi over 4, this angle down here also has to be pi over 4. So I have a 45, 45, 90 right triangle. Well, for this triangle, I know my two legs, which are my horizontal and vertical pieces, are both 1, okay? That's the length of them. But the value of them would be, because we're moving right here, this one would be 1, and we're going down to get to this point, right? This would be -1, not 1, okay? So the length is 1, but the direction is the sign of it, okay? So right here, this is my hypotenuse or my radius, and I know for a 45, 45, 90, that hypotenuse is the square root of 2. So this is a perfect example of why you have to know and just commit to memory where these side lengths go, okay? All right, so here we go. What is sine, because we're ready to answer this question, what is sine of 7 pi over 4? What's the exact value of it? Well, it'd be your y, which is your opposite, over your radius, which is your hypotenuse, right? So -1 over the square root of 2. Okay, good answer, but not the best answer, okay? Because we have a square root in the denominator. So we want to rationalize this, and we want to multiply by the square root of 2 over the square root of 2. That would be equivalent to negative square root of 2 over the square root of 2 times the square root of 2, which is the square root of 4, which is 2. Okay, what's important here is that you start to realize that negative square root of 2 over 2 and -1 over the square root of 2 are equivalent. They're the same. Okay, that's why I have you simplify these. You have to recognize, because what we're going to do is we're going to go backwards. Okay, right now I'm giving you the angle and you're getting the ratio. In the next couple units, we're going to be going from the ratio back to the angle, okay? And so you have to know that, oh, negative square root of 2 over 2 is really another way of writing it as -1 over square root of 2, because it's this one that's going to give us the legs and hypotenuse of our right triangle, okay? Okay, so you got to know that -1 over the square root of 2 is equivalent to negative square root of 2 over 2. Okay, cosine of 7 pi over 4. Cosine of 7 pi over 4 is your x, which is your adjacent, over your r, which is your hypotenuse, right? 1 over the square root of 2. So once again, we got to simplify that. We multiply by the square root of 2 over the square root of 2, which is equivalent to the square root of 2 over the square root of 4, which is 2. So you got to recognize that 1 over the square root of 2 and square root of 2 over 2 are equivalent, okay? And then finally, tan of 7 pi over 4. Okay, tan 7 pi over 4. That would be your y over your x, or your opposite over your adjacent. So that'd be -1 over 1. And -1 over 1 is -1. Okay? And I want you, this would not be the best answer. This is the best answer, okay? Because you can simplify it, okay? All right. And let's turn the page and we'll continue to do some more problems with example number 2, okay? Okay, so for this angle, it's a negative angle because I'm rotating clockwise, right? Okay, so I know this is 0 pi over 3. To right here would be -3 pi over 3. Okay, and knowing that that's -3 pi over 3 and my rotation is -4 pi over 3, that helps me to figure out the reference angle. Because I was at -3 pi over 3, I have to go 1 more pi over 3, right? 1 more pi over 3 in the negative direction to get to this terminal side right here. So that means this reference angle right here has to be pi over 3. So my reference angle, that reference angle is important because that allows you to put the correct the correct sides on each of the sides of the right triangle. Okay, so I'm going to talk about this point right here. Okay, I'm going to draw to the x-axis and do not draw to the y-axis. Okay, so this is my right angle. Okay, and then I know if this is pi over 3, this is pi, this angle up here is pi over 6. I always know that opposite pi over 6 is going to be a length of 1. Now, from the origin, I'm going left. So that's not just 1. It's actually -1. And opposite pi over 3 is the square root of 3. But I'm going up, right? I'm going left and up. And up is going to be positive. So that'd be positive square root of 3. And this is a 30, 60, 90 right triangle. So this hypotenuse, or my r, has to be 2. Okay? All right. So we've got, so the angle that we rotated allows us to figure out the reference angle, and the reference angle allows us to figure out the side lengths of our special right triangle. Okay. All right. And then because we have the x, y, and the r, we can figure out all 3 trig functions. Okay. Whoops. Okay. So sine of, I'm going to write it correctly this time. Okay. Sine of -4 pi over 3, because that's the angle we're doing, must equal, okay, our opposite over our hypotenuse. So in this case, our opposite would be our y. So square root of 3 over 2. And that's the final answer, okay? That's the correct answer, and it's the best answer, okay? Cosine of angle negative 4 pi over 3 is equivalent to the adjacent over our hypotenuse, so our x over our r, so this would be negative 1 over 2. Or if you chose to, you could write it like this. Put the negative in front of the fraction. And then tan of angle negative 4 pi over 3 is equal to, okay, so tan is opposite over I keep saying hypotenuse, opposite over adjacent, okay? So that'd be the square root of 3, because that's my opposite, or my y, over my x, which is negative 1. So the square root of 3 over negative 1, which would be negative square root of 3. I don't want you to leave your answer like this. It should simplify to this, okay? All right, so now we're going to move on. Okay, so up to this point, everything gave us special right triangles. Okay, the next one, I'm going to tell you, we're not going to get a special right triangle out of it. Okay, you can't. We're going to do it a different way. Okay, so right here, we rotate, okay, and we land on an axis. So you're going to have to do this, okay, when you land on the positive or negative x or y axis. Okay, so if you land here, 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 or here, your rotations land you on any of these points right here on an axis, okay? Then we're gonna have to come up with our own radius, okay? Because it hasn't been given to us, okay? So the simplest radius would be 1, okay? So let me explain to you how we're gonna do this, okay? So this is gonna be 1. That's all you have to do, okay? So r is gonna be equal to 1. We're gonna let r be 1 for the circle, okay? If the radius is 1, what you can do is you can figure out all of these points. Okay, so this point right here, if this is a radius of 1, right, then I know my x coordinate would have to be 1 and my y coordinate would have to be 0. So the x coordinate would be 1, the y coordinate would be 0, and my radius would be 1. Okay, up here, okay, my x would be 0. I'm going to have to go just simply up, right? So this is I'm going to go up my radius, which is 1. So my x would be 0. My y would be 1. My radius is still 1, okay? This point right here, I'm going to have to go left 1. So that would put me at negative 1. My x coordinate would be negative 1. My y coordinate would be 0, okay? Now this point right here, okay, so this point right here, and that's the one I'm actually going to figure this one out, right? My x is going to be 0, because I'm not going to, from the origin, I'm not going to move left to right. I'm just going to go down, right? But because I'm going down and I'm going down the radius 1, right? That coordinate is not 1. It's actually going to be negative 1. So our y is negative 1. Okay, because we're right here at this point, and that's where we rotate. That's where the terminal side landed, right, on the negative y-axis. I now know my x is 0, my y is negative 1, and my r is 1, okay? So sine of angle 3 pi over 2, and this is where you can't really do the opposite. You have to go to because there's no right triangle. So there's no opposite leg and adjacent leg and hypotenuse anymore, right? You have to go to what is sine? Sine is always your y over your r. Well, what's your y? It's negative 1. What's your r? 1. So this is equal to negative 1 over 1, which is equal to negative 1. And then cosine of angle 3 pi over 2. Again, you have to go to the definition of cosine and sine for x's and y's and r's, okay? So cosine of 3 pi over 2 is your x over your r. So your x in this case is 0, your r is 1, so this is equal to 0 over 1, which is equal to 0. And then tan of angle 3 pi over 2, you can't do opposite over adjacent, okay? You can't do opposite leg over adjacent leg. You're going to have to do y over x. So what's our y? Our y is negative 1, and our x is 0. So this is equal to negative 1 over 0. Now, this is dividing by 0, Okay, so actually, this is undefined. We can't figure this out. Okay, it has to do with the last unit we did. Well, actually, 2 units ago. Okay, you cannot divide by 0. Okay, what's going to happen is this is going to, when we divide by 0, this is either going to go to infinity or negative infinity, depending on what side we're going to. Okay, all right, so we're going to, this is going to cause a vertical asymptote when we go to the graphs of tangent. Okay, you don't have to know that right now. You just have to know that dividing by 0 is undefined. Okay, all right, so now we're done with example 2. All right, and now I want to move on to example number 3. Okay. Okay, example 3, what I want you to do is find the value of each trig function. So I've given you an angle, okay, and I want you to find the trig function for that specific angle. So we're gonna put, this is actually the ultimate, what I want you to be able to do is this right here. This is the bread and butter, okay, of this whole unit. This is the most important thing, okay, all right? By far, this is the most important thing. You will not be able to do calculus if you can't do these, okay? All right. It's going to take some time to get them right, though, okay? I know, okay? But you should get these 9 out of 10 times, actually 99 out of 100 times, you should get these right, okay? Okay, once you get good at it. It takes practice to do that, though, okay? Okay, so sine of 5 pi over 6. So we want to draw angle 5 pi over 6. That's the first thing we're going to do. Okay, so I'm going to draw my y-axis and my x-axis. I'm going to draw my angle diagram, okay? I want to rotate 5 pi over 6. Okay, so, and I want to go in the positive direction, so I'm going to go counterclockwise, okay? Now, I know right here, this is 6 pi over 6, and that's too much rotation because I only want to do 5 pi over 6. So I gotta, if I go to 6 pi over 6, I need to back off a pi over 6 to get to 5 pi over 6. So I'm just going to draw my angle right here. Okay, so this is going to be the angle of rotation. That is 5 pi over 6. Okay, and I'm not drawing the circle, but there's a circle here. Okay, this right here is angle, the reference angle would have to be pi over 6. I'm going to drop my vertical here. Okay, here's my right angle. If this is pi over 6, this one has to be pi over 3. Opposite pi over 6 is 1. Now I'm going up, so that's a positive 1. Opposite pi over 3 is the square root of 3, but I'm going left, right? I'm going left to get to this point. So this would be not square root of 3, but negative square root of 3. And this is my hypotenuse or my radius, which is 2. Okay, so what is sine of 5 pi over 6? It's your opposite over your hypotenuse, right? So this would be y over r, right? So it'd be 1 over 2. So sine of 5 pi over 6 is 1/2. Okay, and you're going to do this so much that pretty soon this diagram, you're going to be able to do this diagram in your head. If you do this enough, you're going to be able to do the diagram in your head. Okay, all right, but the way to get there is to do a lot of problems. Okay, cosine of angle pi. Okay, all right, so angle pi, I'm going to rotate to an angle of pi. That'd put me right here. So this angle is pi. Now I landed on an axis, right? So what I'm going to do is I'm going to define what I want the radius to be. The simplest the radius could be is 1. So I'm going to say r is equal to 1. My radius is 1. That's the easiest one. You could actually make it be anything you want to, but I would make it the simplest one, which is 1. Okay. Now, if the radius is 1, right? This is a point on the circle that's going around. Okay. Then that means this has an x and a y coordinate. And because the radius is 1, this x coordinate, I'd have to go left to get to this point, and I have to go left 1. So my x coordinate would be -1, and I didn't have to go up or down to get to this point, so my y coordinate is 0. So I know my x is -1, my y is 0, and my r is 1. Cosine is x over r, so that'd be -1 over 1, which is -1. Okay, and cosine of pi is -1. Okay, all right, let's go to this next one. Tan of 3 pi over 4. Okay, tan of 3 pi over 4. So I'm going to draw a diagram. And we're going to rotate, and you should draw a diagram for every single one of these homework problems when I ask you this, okay? Tan of 3 pi over 4. I know that 4 pi over 4 is right here. 4 pi over 4, I only want to rotate 3 pi over 4. So 4 pi over 4 is too far. I need to back off 1 pi over 4. Okay, so this is my angle that I rotated. This is 3 pi over 4. Okay, I know this angle right here, this reference angle, is how far I had to back up, right? And which is pi over 4. So I'm going to draw in my right triangle. Since this is pi over 4 and this is a right angle right there, this is also pi over 4. And I know for a pi over 45, 45, 90, my legs are 1, 1, and my hypotenuse is square root of 2, okay? So that means this leg right here, because I'm going left and it's an x coordinate, this is -1. This is my y, which is +1 because I'm going up. And then my radius or hypotenuse would be the square root of 2. Now, what's tan? It's your opposite over your adjacent, or your y over your x. So it is 1 over -1, which is -1. So tan of 3 pi over 4 is -1. Okay. Let's go -2 pi over 3. Okay, so sine of -2 pi over 3. Drawing a diagram. I now know, because this is a negative angle, I'm going to rotate clockwise, right? But if I rotate clockwise right here, this would be -3 pi over 3. Now that's too much rotation because I only want to do -2 pi over 3. So that means I'm going to back up. And you know what? I should say this. This is 0 pi over 3. Now, to get what this one is, okay, that's going to be halfway in between, right? So this is -1.5 pi over 3. And that just helps us to know, is it in this quadrant or this quadrant? -2 pi over 3 would have to be in this quadrant, right? Because -2 is bigger than -1.5. So right here would be our rotation. This is the angle that we rotated, and it's -2 pi over 3. So that means, okay, so I'd have to rotate how much more to get to -3 pi over 3, and that would be my reference angle. So this angle right here is pi over 3. So I'm going to draw to my x-axis. You always draw to the x-axis. This is my right angle. This is pi over 6. I know opposite pi over 6 is 1, but because I'm moving left from the origin, this would be -1. Okay, opposite pi over 3 is the square root of 3, but I'm moving down, so that would be negative square root of 3. And my hypotenuse or radius would be 2. Okay, so what is sine of this? Well, sine would be your y over your r, right? Your opposite over your hypotenuse. Negative square root of 3 over 2. So this is equal to negative square root of 3 over 2, which could also be written negative in front of the fraction, square root of 3 over 2. If you write it either way, they're both right, okay? Okay, hopefully this is making sense to you now, okay? Everything that we were doing earlier, okay? I'm going to slide this up a little bit to do these last two problems. Okay, cosine of pi over 2. What does this equal, right? So we're going to draw our diagram. Okay, this would be, because I'm counting by 2's, this would be 2 pi over 2. So this is pi over 2, right? And this is 0 pi over 2, which means I land right here on the positive y-axis. Okay, so we get to pick the radius when that happens. Okay, there's no special right triangles for these. Okay, so r is going to equal 1 because we're always going to just let r be 1. That's the simplest version. Okay, then that means the coordinates of this point right here would have to be, because I'm not moving left or right, my x would have to be 0. I'm going up, so my y is going to have to be the same as the radius, so that would be 1. Okay, so what is cosine? Cosine is your x over your r, so that would be 0 over 1. And 0 divided by 1 is 0. Okay, now 1 over 0 is not 0. 0 over 1 is 0. Okay, all right. And then the next one, tan of 3 pi over 2. Okay, what is that one equal to? Okay, so where is 3 pi over 2? Okay, so right here is 2 pi over 2. This is pi over 2, 1 pi over 2. This is 0 pi over 2. Then this would have to be 3 pi over 2. And so once again, we're landing on an axis, right, for this one? So right here, we're landing right here. So when we land on here, 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 or here, we're going to pick our radius to be 1. Okay, if our radius is 1, what's the x and y coordinate of this point right here? Okay, because that's a point on this circle that we're going around of with radius 1. Okay, so if we go, we're going to not move left or right at all. So that means my x coordinate would be 0. I'm going to have to move down. So that means my y has to be negative, and I have to go down the distance of 1 in the negative direction. So that means my y is negative 1. Okay, so what's tangent? Tangent is, what's tangent of 3 pi over 2? Well, tangent is y over x. So it's going to be negative 1 over 0. Well, what's negative 1 over 0? It's undefined, right? So we write undefined. Okay? And that's what I want you to be able to do. I want you to be able to find. That's the objective today. I want you to be able to, if I give you angle like 7 pi over 6 or 5 pi over 3, that you're able to locate it and put on the sides of the right triangle or the coordinates if it lands on an axis, and then you're able to tell me the value of the trig function, okay? All right? So that's what I want you to be able to do today, okay? So this is 420. Okay, this is Monday, all right? And I want you to do worksheet TF5, okay? And take a look at what's gonna happen, okay? So tomorrow, what we're gonna do is all 6, I'm gonna introduce 3 brand new trig functions. They're actually just the reciprocals of the 3 we did today, okay? And then we're gonna have 2 days of just practice. So these aren't gonna be, I'm not gonna give you video lessons on TF7 and TF8 because they're just practicing. So you get really good at this, what I taught you today, okay? Along with the other 3 trig functions, okay? And then we're gonna do a review. So this is gonna be Tuesday, Wednesday, Thursday, and this is gonna be Friday, okay, that we're gonna do, okay? All right, you guys, make sure you're watching the videos, okay? And good luck with this. And you guys, if you have any questions, just reach out. I do not mind going on Zoom with just one of you and just put, I can talk through the doc camera and show you exactly if you're having any difficulties with this at all, okay? Just send me a message on Remind or through Google Classroom or email. I'm checking all those all the time. And just reach out to me and just let me know, Mr. Mitchell, I'm having a tough time with this. Okay, and we can talk one-on-one. I do not mind doing that. I'll take time. If it's 9 o'clock at night, I will do that for you guys. Okay, I have no problems doing that to help you out through all this. Okay, just reach out if you're having a tough time. Okay, all right. You guys take care. I really care for you. Have a blessed day. All right. Bye-bye.